All right, another question that I had, some people who were a little unsure, let's see if I can move my face out your way, was the difference, or maybe I'll put me right in the middle, was the difference between the null and the alternative hypotheses. All right, so null hypothesis is one that seems crazy that we waste our time writing it because we're hoping to reject it. But it is there for a reason. And so the null hypothesis is always going to say, depending on your experiment and how it's set up, it may say there's no difference between the groups. Or if you have, like the example we're going to use with the mice and the kind of food they want, they would have no preference. So that's kind of how you would say it. There will be no difference between the groups being studied or something like that. So it's always going to be the same thing, no matter the experiment. It's always going to say kind of the same thing. What it means is that the independent variable does not cause the dependent. There is no relationship. So if I'm shining different color lights on plants, if the null were accepted, that would mean that that color light has no impact on plant growth. Okay. What we would also expect with a null, if the null is accepted, is that our observed values will match our expected. So think through with your experiment with the dice, where you were doing the chi-square and you were rolling the dice 60 times. And so we're expecting for 10 to get 10 ones, 10 twos, 10 threes, 10 fours, 10 fives, and 10 sixes. If the null were true, if it were accepted, then what we would expect to see is 10 ones, 10 twos, 10 threes, 10 fours, 10 fives, and 10 sixes, or numbers that are so close to that number, to the tens, that it is not statistically different. Okay, so that's your null hypothesis. Your alternative hypothesis is what you generally think of when you think of writing a hypothesis. You are going to say there is going to be a difference, or there is going to be a preference, and it can be non-directional, which just means you say there's a difference, or you can be specific. You can say, I think there will be more sixes when I roll the dice 60 times, or I think there will be more twos. In this case, with your alternative, the independent does have an effect on the dependent variable. So it is causing, going back to the plants, the color of light does impact the height that the plant grows. And so your observed values and your expected values would not be equal if your alternative was true. So let's look at this with an example. We have 15 mice and we want to know what food they prefer. Mouse pellets that we bought at the store, cheese, or carrots. My null hypothesis would be that the mice have no preference for food, or that there would be no difference in the number of mice at each food source, because that means that the food choice does not impact what they eat. So you're going to see about 5 mice eating the mouse pellets, 5 eating the cheese, and 5 eating the carrots. So your observed values when you actually do the experiment would come out to match your expected 5, 5, and 5. Our alternative is that there would be a difference. The mice do have a preference. They do want cheese. And again, you could go non-directional and say they will just have a preference, or you could be specific and say the mice will prefer cheese, or the mice will prefer carrots, or the mice will prefer the mouse pellets. What you're saying here with your alternative is that your independent does have an effect on the dependent. So the food choices will impact how many mice are at each choice. And so our observed values do not match our expected. Our expected are that we would see 5, 5, and 5, but what we might actually see is 1, 12, and 2. And so that would, when we did our chi-square, and we would reject our null and say that they actually do prefer cheese. So that is the difference in between a null and alternative hypothesis, and that is how you should write them. I hope that helps, and if you have more questions, let me know.